Hello students, welcome once again to Dr. Saras's classes. We are back again with the same type of group theory videos. I know there are many students who must be getting, irritated with these group theory videos, because group theory in itself is a chapter that irritates most students. But I would suggest you students to just be calm, just be relaxed, okay, and go through these videos. Okay, these videos are absolutely helpful for you to crack the competitive exams. Just go through the videos, get ready, okay, and that is enough. Okay, so in the previous video we were talking about some important results. If I go back to the previous slide, okay, here it is. Some of the important results were given to us. How groups are isomorphic. Then we learnt about the integer part, where n is greater than 1 and g can be generated by an element a. Be a cyclic group of the order n, since e is equal to a to the power 0, a to the power 1, a to the power 2, right on to a to the power n minus 1 are distinct, all distinct points, different points. And for a positive integer m less than n, then a to the power m is the generator of the group G if and only if m comma n is equal to 1. We get the number of generators of G is phi n. That's how you can find the number of generators of G, by using phi n. Okay, moving on to our next part. In today's topic, after we have finished the 10th part, today we are going to talk about the 11th part. What does it say? It says a group G, let G be a group, anything, a group G, whatever you can say. Let G be a group with at least 2 elements such that G has no subgroup other than E and itself. Then G is a cyclic group of prime order. See, I told you, I was explaining this, right? So what does it say? Let G be a group, okay, where there are no other elements except for E and some other elements, say A. Alright, then you can see that G is a cyclic group of prime order. What is the order of this group? Order of G is 2. It's prime number, right? 2 is a prime number, isn't it? So order of this group is G, and the order of and this group is cyclic because it can be generated by both these elements. It can be generated by E also, it can be generated by the element A also. Alright, very simple concept, students, very simple concept. Just grasp the concept, just grasp it. Very simple concept. Okay, it says that if G be a group with at least 2 elements, there will be 2 elements in the group, and such that the G has no subgroups. Okay, there are no subgroups in G other than only E and itself. Okay, so the subgroups of G will be like a subset, subgroups SGs of G. First one is E and the other one is A. Okay, yeah, EA itself. Alright, so these are the subgroups of G. Okay, and then G is cyclic group of prime order. You can see that G is cyclic group of prime order. Okay, then G will be a cyclic group of prime order. The focus word over here is the cyclic group. It will be a cyclic group and it will be of prime order. Let's move on to the second point, 12th point. What does the 12th point say? Any subgroup of the additive group of integers is of the form n or nz, where n is some non-negative integer. What does it say? It says any subgroup of the additive group of integers. Additive group of integers, how do we denote that? Additive group of integers z plus. From here you will get many subgroups. Okay, so if you take any one of those subgroups, let's say SG1, subgroup 1, taken from here, if you take any one of those subgroups, okay, any subgroup of additive group of integers is of the form n or nz, where n is some non-negative integer. N will be some non-negative integer. That means n will be a positive integer. Simple logic. I don't know why they didn't write positive. They're writing non-negative. Sometimes, sometimes what happens is there are the notes that are given by, no matter which book you go to, which book of group theory. Okay, it's not necessary that these notes are only important. No matter which book you go to of group theory, you will find words that they could have made it much more easier. Like non-negative could have been read as positive. Non-negative means positive, so they could have written a word like positive rather than writing non-negative and confusing the students. But you write positive, you don't write non-negative, where n is some positive integer. Alright, students, so don't think that these notes are only the special notes. You will find the similar type of notes in each and every book. Okay, no author is going to give you anything hi-fi or beyond what is what has been discovered by the mathematicians in group theory. The authors are not going to write something else. So if some book is denoting G as a group, then the other book will also denote G as a group. 10 books like that will denote G as a group. Understood? No. So you don't need to worry about the words of the group. You can make it easier according to your own way. Moving on to the 13th one. Let G be a finite group of order G be a finite group and D of order G. Then the number of cyclic subgroup of order D of G is equal to number of elements. So number of cyclic groups, cyclic subgroups, sub-GRs will be equal to what? Number of elements of order D in G divided by the phi D value. Okay, phi D value, where phi is Euler's phi function. Let's rub off these red markings and let's use a highlighter so that you understand what I have marked. Make sure you concentrate on this formula because I will give you an example. Not now. I will give you a mathematical example as to how you can find the order of group. Okay, I'm sorry, how you can find the number of cyclic subgroups. Okay, from that formula. Okay, when we will be talking about Euler's function, then if you remember, I told you at the first page what was the topics that we were going to do. If I go back to the first page, because I have the slide here, so here is the first page. So these were the topics we were going to do. I have already completed on till this third one. I have already this third one I have completed on. Then when we will do the Euler function, we will learn about how we can find the number of subgroups. Okay, going back to the same slide. Okay, next one is the 14th one. Now these two are connected. Okay, this and this. I want you to mark these two important. I want you to quickly make sure that these two are important points and they are connected to each other. It says G be a cyclic group of order n, then the number of subgroups of G is equal to tau n. Tau, this is tau, T-A-O, I think T-A-U, tau, not O, T-A-U, tau. Okay, it's an alphabet, it's a Greek alphabet. Okay, so both of these points, the point number 13 and the point number 14, are talking about what? Finding the number of subgroups, right? So in the first, in point number 13, you can find the number of subgroups by using the formula, which is equal to number of elements of the order D. Okay, number of elements of the order D and divided by phi D. Okay, where phi is the Euler function, and in the 14th part you can find the number of subgroups of G, which will be equal to tau of n. Okay, and n is whatever it will be. given to you. Okay, students. So students, that's it for this part of group theory. Trying to make the videos short and small so that you can split this up into multiple videos. Okay, where you don't have to go ahead and learn one thing continuously and continue and continue and continue. That way you will never learn anything. Split it up into parts, learn it part by part, like the way I'm showing you, like the way I'm splitting up the videos, some parts here, some parts there, some parts there, how we split up abelian groups, how we split up cosets, how we split up so many things, isn't it? Special linear groups, normal groups, we've split up so many groups here, subgroups we split up, order of groups, we have split it up into short videos so that you students can understand better. Okay, students, so students, you keep taking as much help as possible from Dr. Saurav sir's classes, because you already know that all the help that you'll be needing will be provided here at Saurav sir's classes. Thank you for watching, students. We'll continue this in the next video. Bye bye.